Hello and welcome to finding an angle using trigonometry. Please make sure you have page 36 in front of you for this particular video. So we're going to start with this first triangle, and what I'd like to do is for you to label these sides starting with 5 and 13. So we'll call that 5 and 13, and we're going to look for this particular angle x in this case. So we're going to follow the directions, and it says specifically to make a ratio using the trig functions. So this is my opposite, and this is my hypotenuse. So the trig function that deals with opposite and hypotenuse would definitely be sine. So we're going to write sine of theta equals opposite over hypotenuse. And then we're going to write sine of theta, or x, equals 5 over 13. Now, this is new to all of you, since we typically do not have to try to find angles, but we are going to in this case. In order to get rid of this sign, because remember we're trying to solve for theta in this case, we have to use what's called inverse sine. And it's on your calculator as inverse sine. This little -1 right here is talking about the inverse. You have an inverse cosine button, and you also have an inverse tangent button. So I'm going to show you where it is. On the calculator, you are going to look for this particular inverse sine button. You see it's there in blue, inverse cosine and inverse tan. So in order to get to that button, we need to press the second button first. So this is important, write this down please. Whenever you are looking for an angle, you must use the blue second button and then the trig function on your calculator. If you do not do that, you will actually be taking the sine, cosine, or tangent. You won't be finding the actual angle. So back to here. In your calculator, you're going to press second sine and 5 divided by 13. And the calculator spits out an answer. In this case, it's spitting out 22.61986495. And almost always, you are going to round to the nearest degree. So in this case, this would be 22 degrees. So let's take a look at another couple of examples, and we'll start with number 1. So find the value of x in each triangle, round to the nearest tenth of a degree. So be careful, this one says nearest tenth of a degree. So I'm starting here. This is my opposite, and this is my adjacent. So which trig function deals with opposite and adjacent? You got it. It would be tangent. So tangent of x is equal to opposite over adjacent. And then you're going to write tangent of x equals 7 over 10. In your calculator, make sure you press second tan, 7 divided by 10, and it spits out x is equal to 34.99, so it would be 35.0 degrees. So that's question number 1. Moving on to question number 2. We are going to pretend that we're standing here, and this is my opposite side, and this is my hypotenuse. So I'm going to use sine. Sine of x is equal to opposite over hypotenuse. And then I'm going to write sine of x is equal to 5 over 18. And in my calculator, I'm going to press second sine, 5 divided by 18. And it spits out 16.12762,021. So 16.1 degrees. Now, if you happen to have gotten the number 0.0048481178, then you did not press the second button. Please make sure you're pressing the second button whenever we look for an angle. Remember, whenever you're looking for an angle, you must press this blue second button. Okay, now we're going to take a look at these questions. We'll start with number 3. We'll pretend that I'm standing here. This is definitely my adjacent side, and this is in fact my hypotenuse. So the trig function that I'm going to use is going to be cosine. I'm going to write cosine of theta is equal to adjacent over hypotenuse. Then I'm going to write cosine of x is equal to 3 over 15. And then please make sure you press the second cosine button, 3 over 15. And its x is equal to 78.46304097. So when I round it to the nearest tenth, it will be 78.5 degrees. Okay, all of these are almost identical, except we chose different trig functions. In this case, we use cosine. In the other case, we use sine, and we also use tangent. We're going to skip down to question number 7, a word problem. Communications company is building a 30-foot antenna to carry cell phone transmissions. A 50-foot wire is shown. And then it says, find the nearest degree, the measure of the angle that the wire makes with the ground. This is the wire, and this is the ground. So the angle in question is, in fact, this one. This is my hypotenuse. This is my opposite. So the trig function that deals with opposite and hypotenuse is going to be sine. Sine of theta equals opposite over hypotenuse. Then I'm going to write sine of x equals 30 over 50. And I'm going to type it in my calculator using the second sine button. Second sine, 30 divided by 50. And it spits out 36.86989,765. And then when asked to round to the nearest degree, the correct answer would be 37 degrees. Keep in mind that if this is 37 degrees, we could easily calculate this to be 53 degrees since they are complementary. Okay, and the last thing about this page, which is kind of ironic, I don't know if anybody noticed it or not, but look, it's 37 degrees and it's page 37. Who knew? The answer was right in front of us the whole time. Okay, let's move on to the next page. Okay, so on this next page, I'd like to start with question number 8, and it says in right triangle ABC, this is the important part, that the measure of angle C is 90, so we'll label our triangle this way, ABC. AB is 20, AC is 12, and BC is 16. Find the nearest degree of the measure of angle A. So I'm going to put an X right there. Now in this case, we have a whole bunch of different options. We could use sine if we wanted to. So we would do 16 over 20. We could do cosine if we wanted to. We could do 12 over 20. Or we could even do tangent if we wanted to. And we could do 16 over 12. So what I'm going to choose right now is tangent. You could have chosen any of those trig functions, would have been fine. Just make sure that your side lengths are in the right spot. So tangent of theta is equal to opposite over adjacent, and then tangent of theta or x is equal to 16 over 12. And in your calculator, you're going to press second tan 16 over 12, and you're going to wind up with theta being equal to 53.1301 ... So 53 degrees, and that's your correct answer. One more question, and then I'm going to leave you alone. Question number 10. It says the accompanying diagram shows a flagpole, 2 cables, 16 feet, R and S. The length of the 2 cables combined is 50. So we know that S plus R is equal to 50. And it says if cable R is attached 12 feet in the ground, and we know that this is 16, we have a couple of different options. I could potentially use the Pythagorean theorem to get the length of this hypotenuse. So in that case, it would be a squared plus b squared is equal to c squared. And I would do 16 squared plus 12 squared equals c squared. 16 squared is 256 plus 144 is equal to c squared. C squared equals 400, and C is equal to 20. Now, with that, you could have realized that that was a 3, 4, 5, and just everything was multiplied by 4. So it became a 12, 16, 20. So again, you could either use the Pythagorean theorem or your triplets. Now we know that since R is equal to 20, S must be equal to 30. Again, it says that the sum of the two wires is equal to 50. So this piece is 30, and now we're going to get to the trig finally. This is the angle that we're looking for. So this is my opposite, and this is my hypotenuse. I should probably use sine. Sine of theta equals opposite over hypotenuse, and sine of x is equal to 16 over 30. And then when I type it in correctly, I wind up with x is equal to 32 degrees. Before that was rounded, it was 32.23, 32.2309 dot dot dot, and it says to the nearest degree, so it's 32 degrees. Okay, so what I'd like you to do now is go back to the questions that we did not do together on these 3 pages. Pages 36, 37, and 38, and I'd like you to complete those. So I'm going to write it on the bottom here. Okay, so you're going to complete the rest of the questions on these 3 pages. So complete the rest of the questions on pages 36, 37, and 38. Thanks, and I'll see you tomorrow.